Bismillahirrahmanirrahim. In this session, we will discuss exercise 9.4 from additional mathematics course on the topic of trigonometry for IGCSE and O level students. In this session, we have to plot functions, the following functions. That is defined from 0 degree to 360 degree from all four quadrants. So for each functions we have to write down the amplitude, magnitude, that is, and the period and the coordinates of the maximum and minimum points where these functions have a maximum value or a minimum value. So we have to solve all the six, and after obtaining this, we have to sketch the graph of each function in a part A and use graphing software to check your answer also. So we will solve this part 1 here. Since this is the trigonometric function, we see that y is equal to sine x, and this increases to 0 to 1 here, and then from 1 to 0 here, from 0 to -1 here to 70 degree, and then it reaches again to 0. So from here this is 0, 1, and here it is again 0, this is -1, and then again 0. So for cosine function, here we have a 1, and then we goes to 0, and then -1, and then again 0, and from there we gets 1. So this is the way that we plot. Similarly, this is tangent, and it goes like this. From 0 to 90 degree it goes to here. In a second quadrant, from 90 to 180, this is negative, and from 180 to 270, again third quadrant, its value is positive, and in the fourth quadrant again negative. So this is the trend that we will use, and we have already solved this graphical representation in a very initial lectures on the topic of trigonometry. So this is exercise 9.4, and 0 to 360 degree plotting amplitude, period, and coordinate of axis. So amplitude is 7 because cosine value is maximum value is 1, and it's multiplied with 1 multiplied by 7. So this will be the maximum value, that is the amplitude. And from 0 to 360 degree it completes this period. So this is a periodic function, and it will repeat after that. So this is the total period is 0 to 360 degree. And in second case, fx function is 2 sine 2x, and we see that the sine function is this. This is basically a sine function. This is simple sine function, and this is multiplied by 2. So we just multiply. If we plot sine function and multiply it by 2, we will get this result. So this value, sine gives value 1, and we multiply with this coefficient, so it becomes 2 sine x, means sine x value is maximum value is 1, multiplied by 2 is 2. Similarly, -1 here at this point, this is -1 multiplied by 2 is -2. While 2 sine 2x will be represented like this. It will repeat here. So this will be here. Maximum value will be here, and then this value, period is double. So this period is, its sine 2x period is basically from here to here. So its period is from 0 to 180 degree for this function, while the amplitude is +2. Right? In the third case, we have fx is equal to 2 cos 3x, and this is cos 3x. So cos 3x is basically 3 periods. So 120 degree, 240 degree, from here 120 to 240 degree we have this plot, and from 240 to 360 we again have the same plot. So from here to here, from here to here, from here to here. So we have three cosine function, and cosine value is, maximum value is +1 and multiplied by 2, so the magnitude is 2. So this magnitude is 2 and the period is basically 120 degree, because after this it will keep repeating. Similarly for this 3 sine half x, for half x this is 360 degree, so its period is not incomplete, so it will goes to 720 degrees. So the period of this function is 720 degree from 0 to 360 multiplied by 2, because it's not completed here, and the magnitude value is 1, maximum value is 1, so 3, so the magnitude or amplitude is 3. So actually let's plot this part 7 cos x. So this is 7 cos x. This function is basically 7 cos x. Fx equal to 7 cos x. 7 is here at 0 degree. This is 7, and at this 90 degree we have 0 value. At 180 degree this is again minus 7, and here we have 0 at 270 degree, and here is +7 again. At 360 degree this value is 7. If place 360 degree the value will be 7. At 0 degree this value, cos 0 is 1 multiplied by 7, so this is the amplitude. So the amplitude is 7 and the period is 360 degree, because this is x is has a graph value from 0 to 360 degree. After that it will keep repeating. So this is part A. Now in part B we have to plot 2 sine 2x. So this is simple, this blue curve is simply sine x. If we multiply with 2, then it becomes like this here, and then like this, and then like this to here. But this sine x is simply magnitude, maximum magnitude is 2 at 90 degree. But in case of sine 2x, this has a double period. So in sine 2x multiplied by 2, so this is 2 here, and after that at 90 degree this is at 90 degree. At 90 degree multiplied by 2 is 180 degree. So at 180 degree sine, here if we place 90 degree multiplied by 2 is 180 degree. At 45 degree multiplied by 2 is 90 degree. At 45 degree this value is maximum. At 90 degree this becomes 180. At this value, which is 135, it's become 270. And here at this 180 degree it becomes 360, so which is 0. So this is and we are multiplying the maximum and minimum values with this coefficient. So here we have this. So the period is from here to here 180 degree, and the maximum coordinates are 45 degree, and magnitude is 2. This is 225 degree here, sorry here. This one 225 degree and 2, this is the maximum values and these are the minimum values. This is 135 and this is 350 degree, and the magnitude is here is -2 and -2. So these are the coordinates. So this is simple plotting. Similarly, for this 2 cos 3x, we have also plotted the cosine function for basic understanding. This is cos function, and we have 3 cos 2x. So this red one is basically 2 cos 3x. So cos maximum value is 1, which is here. This is 1, and multiplied by 2, so it's represent 2. So here we have 3x, so this period becomes 3. So at this value 120 degree, here the period is completed like this, and after that one more period here, and after that one more period. So we have 3 signals here in this 360 degree. So the period is from 0 to 120 degree, and the amplitude is 2, and the coordinates, maximum coordinates of maximum values are this one, this one, this one, and this one. At 4 places, 1, 2, 3, 4. The minimum values are this, this, and this. Now this one, last one. This is simple sine curve, and here we have 3 sine half x. So this is 3 times. So this graph is multiplied by 3 times and is represented like this because of this half angles. So if we place here 90, then it's become 45. At 90 degree, this is 45. And at 180 degree, here we have 180 degree. At 180 degree, this becomes 90. This is maximum value, and maximum multiplied by 3, so that's why this is 3. So this maximum value is 180 degree, and the magnitude is 3 here at 180 degree. And here we have no minimum value. This is 0 and 0, and this period is basically 360 multiplied by 2, so 720 degrees is the period of this function. Let's solve question number 5. We have 5 fx is equal to 4 cos x plus 1. So we have this plot. So cos x is 4, and we have to add 1. So that's why this minus 4 becomes shift to 1 more values upside. So that's why this becomes 4 to minus 3, and here we have this value. So this function will be plotted like this. At 180 degree, this is minus 1. So at 180 degree, this is minus 1. Minus 1 multiplied by 4 is minus 4, plus 1 is minus 3. That's why this is minus 3. At 90 degree, this is 0. So at 90 degree, the value will be 1, plus 1. This is 0, plus 1. So this is 1. At 90 degree, this value is 1. Similarly, at 270, the value is 0. So this is plus 1. So that's why at 270, this value is 1. At 360 degree, this is 1 multiplied by 4, plus 1 is 5. That's why this is 5. So we have seen this, and the second one is 5 sine 2x minus 2, which will be plotted in a similar way. So we have obtained this one. Let's see this in the graph. This is simple cos function. This blue is simple, just for understanding. Actually, we have to plot this 4 cos x plus 1. So this 4 cos x plus 1 is this. So this is 5 here. At 90 degree, this value is 1. Here at 90 degree, this. At this, here we have 1. At 270 degree, here we have again 1. This is the plot. Similarly, for this 5 sine 2x plus minus 2, this blue one is a simple sine. From maximum value is 1 for simple sine, but since we have multiplying with this 5 and minus 2 is here, so that's why this is 5, and this value, maximum value is 1. 5 minus 2 is 3. So the maximum value will be 3. That's why maximum value is 3. On the other side, this is minus 1, minus 5, minus 2 is minus 7. So that's why minus 7 there, and minus 7 is here at this point. And since this is 2x, so this is double graph from here to here, and then from here to here, repeating the same signals. So that's why the period is double. So here we have the period of this signal is from 0 to 180 degree, and after that it is repeating. So this is part 1. Let's solve this question part 2 in a radian form. This is very, very important. This is part 2, and we are solving this from 0 to 2 pi. Only the difference is the radians, and pi is 180 degree and 2 pi is 360 degree, and we will solve the same using the same technique. Let's see this again. Question 1, cos 3x. So from this 2 pi by 3, which is 120 degree, and repeating. Here the coefficient is 1, that's why the maximum value is 1. 2 here, so the coefficient is 2 here, and the period is again 3 times. In a 2 pi, this becomes 3 signals, 3 sine signal, and here half, that's why only half of this, and after half this for this value. So let's see this clearly. From pi by 2, at pi by 2, this is value is 4. At pi by 2, this value is 1 and 4. This is highest magnitude, and at this point, this is minimum value. This simple blue graph is the sine functions, just for referencing. Similarly, for this cosine 3x, this is cosine 3x. And since the magnitude is 1, so that's why it's 1. If we place 2, then it becomes 2. So this is simple. And the coordinates are written in form of pi, and instead of degree. Similarly for this 2 sine 3x. So sine x is 3 times this one, and this one. Well, the simple sine is from 360 degree to single graph, single signal. And with the magnitude 1, here we have 2, that's why this magnitude is 2. And the period is 2 pi by 3 here, which is 120 degree. Similarly for this one, this is cosine, and this is just simply the half of the cosine, this one, this strands. So this red is basically from here to here. And the remaining half is not plotted because this is only the half x. At 360 degree, this becomes 180. At 90 degree, it becomes 45. At 180 degree, it becomes 90. So if you place value x 180, then it becomes 90. So we can understand why it is plotting like this. So here we have sine 2x plus 3. We have to plot this. So this is simple sine x, and if we double, then it becomes like this, double signal like this. If we plot this and we add 3, so we will shift from here to here. It's the same graph without 3 will be here. We will clamp down to here at 0 to 1, and this, and since it is shifting, so that's why we are adding 3. So simply add 3 here, and we shifted it. Instead of 0, we have shifted it to 3 because of this 3. and at 3 this is repeating plus minus 1. Plus 1 is become 4, minus 1 is 2. So this is the maximum coordinates and minimum coordinates can also be plotted. So this is very easy and very good looking. Similarly for this cosine 2x minus 1, so this is 4 times minus 1, so we have shifted it from here. So this reference is here, this minus 1 is our reference. So we just shifted from 4 to plus 4, we just dropped on minus 1, and here we have this reference. This is our reference line. And this is repeating. Similarly for other values. So this is question number 3. We have the graph ABCX is shown above. Write down the value of A, B and C. So we have to give the value of A, B and C. So this is simple because we already plotted there. So this A is basically the intercept value. This 2 is basically here, A is equal to 2, and B is basically the difference between this 2 to 6. So this is 4. So B is 4, and since this is half, so this C is 1. So because 0 to pi degree sine is plotted, so this is simple. So in question C we have this value. So this C is 1 and B is 4, because 6 minus 2 is 4, so the magnitude is 4. So this is 4, and the intercept value, because we have shifted it to 2, so that's why this is 2. Similarly for this one, we have shifted it at 4, so this C value is 4, and the difference between this 7 and 4 is 3, so that's why this A is 3. A is 3, and since in a 180 degree we have complete signal, so this is 2. This is 2 because this complete sinusoidal approaches in a 360 degree, and since it is completing it in a 180 degree, that's why it becomes 2. Similarly for this 5th part, 6th part, and for sine tangent x, it can be plotted like this. For tangent 2x, this becomes this simple tangent x, simple tangent 2x. So here we have 2, this 1, 2, 3, 4. Here we have 2 periods here we have 4. So this is tangent x, this, while 3 tangent half x is, because x in place of x we have half x. This is like this. So this is all very important, and in the next session we will discuss